Hello and welcome to the RTS framework section 8 part 5. We've just completed our navigation or navigate to command. Well, we've started it anyway. But now we need to build the interface to issue these commands and get them into our command queue. So how we're going to do that is we'll just first rehash over some stuff. So if we recall in our RTS player, just going to duck in here quickly. In our player pawn, we have our inputs mapped for command, and then it's using this interface to send the command to wherever, which happens to be our player controller. So the commands are coming into our player controller, and this is where they're coming in. And rather than build this out, so it's already like, it's getting fairly long, it's not too bad, but we can break this out quite easily to, keep it compact. So what I'm going to do is I'm going to create a player controller that is the command player controller. So just in here, I'm going to create a new class. I'm going to call it RTS entities, and I'm going to inherit from that existing player controller. Rearrange these. We can close the navigation for now. So our previous player controller, we want to grab these. We're going to override them in here. Just set up this constructor. Yeah, I might bring tick over as well. Go and build these. And we'll leave those supers there. We're not doing anything in the original command, but that's fine. We want to keep track of the state of the command. So I'm just going to add a little bit of a enum here. It's only going to be used in this class, so I'm just going to put it up here. And yeah, class. And this will just be none, default state, and then the command is initiated and the command's held down. And we don't need one for end because it's just ended, but this will help us with preview and stuff later on. So let's create a variable for that. And a protected section here. And we'll set the default for that. And then in our command states, we'll update that. So command state initiated. Now I'm just going to copy that. It'll be held. And then in the last one, we'll reset it back to none. This is so when we're doing a preview later, we want to be able to tell it that it's held and we want to update the preview where the mouse is, not where we clicked. And then when we get to this point, the preview of the navigation will be where we clicked. So we want to turn that off. Now let's come down to this endpoint. Probably before we reset that, we need to, if you recall when we were setting up, we had let's have a look at it quickly. It's just in our data. And we had the client command data. So this is what we need to create because this input's coming from, I don't know, the player. So on the player pawn, those inputs are coming in on the client side. So they're reaching our player controller on the client side. So if you checked in all of these commands like is local controller, it would be true. So what we want to do is because these are where the click's happening and we can take the positions from the world on the client, put it in some data and send it to the server for a command. So that's what we're going to do. So we need to create the client command data. And we're going to just pop that in a function. So we'll call it create There we go. Void, it's going to return the struct. So if we have a look what we need in here, it's these things here. Type, has navigation, the target, and the source positions. So I think what we'll do is well, let's create the command type variable, and we'll just set it to something default, idle, and we'll create a variable for the has navigation. And then what we'll do is we'll create some functions to assign those. So we're going to have get command type. It's going to pass that command type as a reference. And it'll need to know if it has navigation to choose that command type. So let's create that. Make this const. I'm going to set that as reference, and this can be const. Actually, no, we need to set that as well, don't we? Sorry. So that'll be by reference, non-const as well. At the moment, we don't really have. We could do a switch here on, like, if you want to hold a key to a navigation command or change it based on what the mouse is over, so you switch from a navigation to an attack. But most commands at the moment that we're going to have are going to have navigation. So I'm going to leave this function here for further implementation. But at the moment, our command type is going to be equal to navigate to, and our has navigation is just going to be true. So that's, just a configuration thing, really. Later on, or in your implementation, perhaps you might have more commands where you need to change between them. So think of like, what's an example? Let's say you have a unit that you want them to attack but not move to the enemy to attack, just attack if the other target's in range. So you might say hold Alt and right click on an enemy, and that would only issue an attack command, not an attack move. So in here you do a switch to see is Alt pressed and only issue the, this would be false and this would be, attack stationary command or something like that. Best I can do for an example. All right, so now we need to, in our client data, we need to get the locations. So we need the source location and the destination location. And the destination, or let's actually change this to target location. That makes more sense. So the command target location. Destination makes sense for a move, but if it's some other command later, it's going to be different. So this one we'll already have, because wherever we click at the start here is going to be our target destination, unless we're doing a preview and moving the mouse around. So let's do a function up here. Sorry, I'm going to jump around a bit here, but we're going to assign a command location. Command target location. What I'm actually going to do is I'm going to make a property for that. Could potentially make this a transform. We want a transform location. I'll make this location for now. I might change this to a transform later. It's just going to be easier to do the raycast to the terrain. Yeah, this just needs to be a location. So in here, we're going to get the mouse position on the terrain. So Initialize a variable here. And that's a function we've previously put in the parent class. So this one's in the, oh, it's in the core player controller. Oh, actually, that's one thing I'm going to do. I just recalled something because I know I'll forget this before we fire up the editor. Because we created this new player controller class, if we come to our actual source player and the project player controller, it's inheriting from the entities player controller. We want to change this to our new one. If you've made a blueprint of this in the editor, this shouldn't affect it. You should be able to just slot this new player controller in and not have to recreate a blueprint or do anything like that. So we just update these. Don't need that. We've got to do that. So now the game's using, we'll incorporate our command stuff. Close that. Right, sorry, sidetrack there. So now we've got our source, our target location set, and what we're going to do is based on the command state. So if the command state is greater than no command state, so it's either initiated or the other one, initiated or held. If it is initiated or held, we're going to use the target location. Otherwise, we're going to use a mouse location, which we'll have to set. I'll just copy this. Put some comments in here. If we've selected a unit and we're moving the mouse around to have a look where we want them to go, then it's going to use the mouse location. But if we press and assign, and we've now assigned a command location, so that's the initiated, and if we hold that down, then we want to use this target location, and then we can start. So we've sort of fixed the preview to the target location, and then we want to rotate and do whatever. So that's what we need to do next, is we need to figure out the rotation. So I only need to do this on if the mouse is held. So actually we still want a rotation even if we don't like hold or drag or anything. So we might just do a rotation always. Oops. So now the rotation, we've got to have two rotations, but one for when we're holding the mouse and we're dragging it around to change the rotation, and another one for when we just click. So what we're going to do is see if the destination is far away from the mouse location. That means we're holding the mouse and it's traveled some sort of distance, and we can use those two locations to set up a rotation. If we have so we've clicked our mouse here, and then what we're doing is we're holding our mouse here. So now we want to get a direction in that direction, and then so this black circle is our fixed command point, and then this red circle, we can move this around to change the rotation at that destination, is what we're doing. So in order to do that, we need to see if the mouse location is actually not in the same location as our command location. So what we're going to do is have a bit of a buffer there. So if the length or the distance between those two is greater than, this is just an arbitrary number, so use whatever works for you. But sorry, it's not destination, target location. So if it's greater than that distance, then we want to create a rotator. So in our rotation matrix, we can make a rotation from X, which is the forward vector, and we can use the mouse location minus the target location, just what we've done above. So basically getting a direction from the command location to the mouse location, and then we can just make that a rotator. So that'll be what we return as our rotation. However, if the command location and the mouse location are less than 150 apart from each other, so basically on top of each other, then we're going to create a different rotation matrix. We can still make it from X. And what we're going to do is we're going to do it from our destination. Well, it's actually reversed, right? So this is 2. So to our destination. So did I do the other one right? Yeah, from our location to our mouse location. Yeah. So this one will be to our location from our source location, which we haven't set yet. So what we're gonna do is if we don't define a rotation, it's just going to get the rotation from our source location, which is where we are now. So back to my beautiful artwork here. If our unit, so this is our unit, he's standing here, and we say move to here, where this black dot is, then if we don't define a rotation, it's going to use the rotation of that direction to the location. So the actual command rotation will be here, like that. Hope that makes sense, because rotations are hard. We might separate this out, so let's do... So here, what we're gonna do for our source location, we're gonna use, so if we've got, let's go back to the artwork. If we've got multiple groups selected, so there's 4 guys here, and we've got 4 guys here, say they're in some awesome line formation. So we've selected these 8 units, and then we're going to say move to here, or here, wherever. For our default source location is we're going to get the average location, so the source location will be something like here, and then that will use that for our calculations with the source. If it was just one group, it'll be here. But if we select multiple, like if we had 3 groups, it'll probably be there again. But that's how we'll figure it out. So what we'll do is we'll basically get all our selected entities and, well, probably just their groups. Actually, we're defining group leads already, so I'm pretty sure. So we can just use the group leads and get their average position, because the group leads are generally the person closest to the center of each group anyway. So we're going to just do a function. Yeah, because that's, I mean, it's assigning the source, but that's going to be what it's doing. It's going to get the... I don't like the terminology. I'm going to call it selected. Let's use that. And this will be passed in as a reference again, non-const, as we're going to set it. So now in here, we need to cycle over our selected. We not access our selected. Make it private, you know. Box select. Oh, selections. Yeah, okay. So we created come to our data. We've got the player selection, and then we created the data for, so this should be what our selected is. So I think I just haven't updated that. So on our player, our original player controller, we want to remove this array from all these points and replace it with our struct. So it'll be like so. It's going to cause some errors. So it'll be this struct, and we can assign these things to it. Probably fix a bunch of broken stuff, let's say. So this will be clear, which is a function we made on our struct. Oh, that fixed a lot of stuff. Clear, didn't fix. So this is just a reference error. So if we come to this function, put an S on the end and get rid of the array. This selected, make that struct. This we're going to rename to selected. So this is, it's a list of the selections, so it's the selected. That's how I'm working it, just to have a different name. Already created more errors. So selected selections is what we'll do to check that now. What's this one up here? Create group selections. So this will need some work. Actually, no, that can stay the same. What we'll do, or where we're using that, instead of just passing in the client pending selections, we'll class in the selections. So it keeps the array, because we use the array in that function. The next one. This handle single selection, and we just need to add it to that selections. So that's adding it to the array of selections in our selected. So this is going to be the same thing here. Just need to reach into the selected. Just because we need the selected is just because we need an overarching data struct for all of our selected groups. Anywhere that we're referencing that array, just add that selections. Pretty sure that remain pending list is the array. I think we're done. Sure, errors will present themselves, but so we should have our selected now, which is a struct rather than an array of structs. And also our client pending selections is the same struct. So now in here we can do the selected.selections. We'll first just check if it's valid. Might do not valid. If it's not, I'll just continue. But if it is, we want to get the group lead. We're just going to pass in the entities. That's what that function does. And if you wonder why I'm not testing if group is valid, is because this is valid does that. That's how it checks if the selection is valid, if it has a valid group. And then the get lead function goes through and gets the lead individual. So that'll ensure that it's always the current group lead, not one that we've assigned earlier. What we're going to do now is we'll add that to the center location, source location, sorry. We'll add the group leads location, sorry, for that. So if there's only one group lead, then we're just going to use that as a source location. But this will go through and do all the group leads if we've got multiple groups selected. And then if we do have multiple, and we'll just average that source location. And make sure you have some sort of check-in here, whether it's greater than 0 or whatever, because you don't want to divide by 0 here, it'll crash. So that'll return our source location. We'll update our source location here, and that'll feed into our rotation. So now we want to create our command data down here. And what did we have for inputs? So we've got, for our constructor here, we've got 2 inputs. We've got type and the has navigation. So we'll just initialize it with that. And then we can set our other parameters. So set target location to our target location. I'm just going to change the name of that one to target rotation. And our source. And I'm not going to worry about source rotation. Here is also where you might want to, because we've got access to the input modifier, so like if you're holding shift or something like that, this is where you might want to add that to the client command as well. Yeah, let's create a function for it. And we'll pass in the command as a reference again. Can't remember if we had this in the data, might have to check. Client command data, missed it. Yeah, no, we don't have it, but I'm going to add it because I think it'll be very useful later. So this will be, there's a number of ways you can do this. You can either pass the modifier itself and assign whatever later based on the modifier, or you can use that function to pass some sort of AI behavior that you want to do. So for example, if I click a command to move some units and I hold shift, you might want them to run, and that might be might be a behavior for run. Or you could just pass the I'm holding shift and then pass that, and the command itself decides what it's going to do. So I think we might just do it that way for the sake of not having to set up a whole state struct. So we're going to pass our modifier, which, come back to here, is the core modifier struct. I'm just going to put this in here. I'm just going to add a forward deck, so I want to include the whole command data in the entity data sort of thing. And we'll call this modifier key. There we go, that'll do. And then back in our command here, so if you did want to make it a behavior or something like that, you'd have a switch in this function here and send the thing, but we can just set it. So that's the reason why I put it in a function, because there's sort of different ways you can do things. This will allow you to flesh it out later. And that can be const. So if you're happy just to pass the modifier key, you could just do the same as this, client modifier data set modifier key. But I think that's a good way to do it. Anyway, moving on. That's it actually. That's all we need to do. And this, we can make this constant actually, because we don't set it again, do we? We just use it. In our command end here, we now have all the data in our client command data that we need. So we can issue that to the server, because the server is where you're going to handle your queue and all that. And we'll make a function for this. And we'll pass out client data. And this will need to be a U function. So we can add the server reliable. And make this const reference. We'll ensure that we have authority. We have authority, it's a RPC, but and we'll check that the data is valid coming through. We'll exit out if any of those aren't right. So now we need to create our command. So that's our client command done. In the next video, we'll continue with creating the command on the server and looking to get it to the queue point. Thanks for watching, and I'll see you in the next part.